So in the last video, we discussed about how do we find the limit of a sequence, and then how do we decide the convergence of a limit. Okay, so we say that if the nth term of the sequence has limit L, then the sequence converges to L. Okay, so basically nth term also decides the convergence of the limit. That's one method. Okay, so the another method is using the squeeze theorem. Okay, sometimes it is hard to find out the limit of a nth term. Okay, it is hard to find out the exact limit of the nth term. In such case, this theorem may help to find out the limit of a sequence. Okay, so what it says is, suppose that an and bn are two sequences, and suppose that both of the sequence have limit L. If the limit of an and limit of bn are equals to L, and there exists n such that if there is a third sequence Cn that lies between an and bn, so not everywhere, you don't need to have the Cn between an and bn everywhere. If Cn lies between an an and bn after certain terms, okay, Cn may be outside, okay, Cn may be outside an and bn for some terms, but if Cn is between an and bn after certain terms n, okay, and after certain terms n, that is for all n greater or equals to n, Cn lies between an and bn, then the limit of Cn must be equal to the limit of an and bn, meaning that after certain terms, if all the terms of Cn lies between an and bn, bigger than an and smaller than bn, then the limit of the Cn will be, it is like sandwiched, right? It is squeezed between an and bn, then that must be equal to the limit of an and bn. That's what it says. Okay, let us do this example. Limit n tends to infinity, sine n over n. Here we know that since, what is the value of sine n? Sine n always lies between -1 and 1, right? Since -1 is lesser equals to sine n is lesser equals to +1, because sine function always lies between -1 and +1, right? Let us divide by n for all of them. Then limit n tends to let me write down that term first. Okay, then -1 over n is lesser equals to sine n over n is lesser equals to 1 over n. So I'm just dividing by n. Okay guys, so I'm just dividing by a constant value for each of those. So inequality, since n is positive, it still holds. Okay, now take the limit. What is the, so this is like, you see that this is like an, this is like bn, this is like cn, right? So this happens for all of the n, for all n. I mean, you don't have to have for all this satisfy for all n. If this satisfy only after certain terms, certain n values, that is fine. Okay, but it holds for all n, so which is even better. Now what is the limit of an? The limit of an, the limit of this an will be 0, right? Because when n tends to infinity, this goes to 0. Similarly, the limit of, sorry, this is cn. Okay, this is cn, this is bn. So what is the limit of bn? Limit of bn is also 0, right? Since the left and right are 0, since the limit of the left and limit of the right are equal, and they're equal to 0, so the limit of the middle, because this middle is smaller than the bigger one and the bigger than the smaller one. Hence, by squeeze theorem, limit n tends to infinity, sine n, right? Sine n over n is also 0. So this is the squeeze theorem. Okay, so there is another example in the book which is also, I like this, I find this interesting. Okay, so let us talk about that example. All right guys, so what it says is, so that the sequence -1 to the n times 1 over n factorial converges and find the limit. So there are two different ways to do that. I will show you both ways there, right? But first of all, I want to do the more complicated way, but it makes more sense with that squeeze theorem. Okay, so what is n factorial? You know that n factorial is equals to it is 1 times 2 times 3 times 4 times, and then 5 times 6 times 7 times, it goes like that, right? Similarly, what is let me find out 2 to the n. This is, you will see why I did that. Okay, so 2 to the n is 2 times 2 times 2 times 2 times 2 times 2 times 2 and so on. You see that now? So which one is, now let us compare. So you see that up to the on the first term, in the first, this is bigger, right? On the second, it is equal, right? On the third, this is smaller. Fourth smaller, fifth smaller, sixth smaller, and so on, right? You see that after the second term, all the terms of n factorial are bigger. Do you agree with that? After the second term, all the terms of n factorial are bigger than the terms of 2 to the n, right? So what I am going to write here is, for n is greater or equals to 2 after the second term, on the second term or after that, you can write that n factorial is bigger than 2 to the n, right? Now if I take the reciprocal, that is 1 over n factorial, I want to write greater or equals to because I'm taking second term as well. 1 over n factorial is less or equals to 1 over 2 to the n. You see that? This is what happens. All right. So 1 over n factorial is less or equals to 2 to the n, right? 2 to the n. Now, what we can say here is, you can say that 1 over n factorial is less or equals to 2 to the n here, right? But if I multiply by the negative value there, you can write like, then you can do it directly too, like we did here. Okay, so that is not a problem. What we will do, and I will show you another method to do that. What you can do this is negative 1 to the n, 1 over n factorial is less than negative 1. Okay, it is greater than negative 1 and less than positive 1. You can do that too. I will show you that way too. Okay, so then what you can write is negative 1. Okay, negative 1, I don't need the parenthesis. Okay, negative 1 over 2 to the n. You see that? I am multiplying this by negative sign. Okay, which is less or equals to negative 1 to the n times 1 over n factorial, because you see that negative 1 to the n can be negative or positive, but if I write negative all the time, then it will be all the time negative. So this thing is greater than negative 1. Okay, and we know that since we multiply by negative sign, if I multiply this by negative sign, you will get this one is smaller than that one, because the inequality will be reversed, right? And which is less or equals to what? 1 over 2 to the n. I can squeeze negative 1 to the n times 1 over n factorial between negative 1 over 2 to the n and positive 1 over 2 to the n. I can squeeze that. Okay, and what is the limit of this? So the limit of this is 0 and limit of this is 0. So hence since the limit of the left side and the right side function are 0, then the limit of n tends to infinity, negative 1 to the n, 1 over n factorial is equals to 0. So why I did this is because you see that this one, you see that this function is small at the beginning. That was smaller. Okay, for the first two term that was smaller, but after that this is bigger. Okay, so that n factorial is bigger. So you don't have to have all the terms smaller, all the terms of an smaller than all the terms of bn or cn. You don't have to have that. You can have at first time, for the first some time it can be bigger, and then after all the terms after that will be smaller, like that. All the terms after that will be n factorial will be bigger than 2 to the n. So 1 over n factorial will be smaller than 1 over 2 to the n for n is greater or equals to 2. That's what we got here. Okay, now then we can see that this converts to 0. So what is the another way of doing the same problem? That's the shortcut way. Shortcut way will be like this. You see that since this is negative 1 to the n, you can write negative 1 over n factorial is less than negative 1 to the n times 1 over n factorial is less than 1 over n factorial, because you see that this term is less than 1 over n factorial, right, for all the terms, for all n values, and this term is greater than negative 1 over n factorial, and less than 1 over n factorial for all the terms. Okay, for any values of n, that is true, since this guy goes to 0 when n tends to infinity and this guy goes to 0 when n tends to infinity, so this limit must go to 0 as well when n tends to infinity. So you could do that like just one line, but I wanted to show that some of the term may be greater than that, but that is still fine, because after all the terms, okay, after the second term, this sequence is bigger than that sequence. So this sequence is smaller than that sequence after the second term. Although the first two terms we're not saying that, that is still fine to squeeze. That's what it is saying. Okay, let us see another absolute value theorem. For any sequence, if the absolute value of nth term of the absolute value of the nth term goes to 0, then the limit will go to 0. For example, on this sequence, look at that. What is the absolute value of an? Limit n tends to infinity. Absolute value of an is what? If you take the absolute value, then the negative sign will be positive, right? So it will be, which is 1 over n factorial, and this goes to 0 when n tends to infinity. When the absolute value function converges to 0, then this and again, one of the important thing is this must converge to 0 to use this theorem. Okay, if the absolute value goes to 0, then the limit, hence limit n tends to infinity of an, that is limit n tends to infinity negative 1 to the n 1 over n factorial must go to 0 as well. If the absolute value goes to 0, then that the original sequence will go to 0 as well, because of the squeeze theorem. Because you can squeeze this sequence between the absolute value. That is because the proof of this theorem is, since limit n tends to infinity an is 0, if this is 0, then you can write negative absolute value of an is less than an less or equals to an is less or equals to positive of an. Since this is 0, this goes to 0 and this goes to 0, the middle one is squeezed between two zeros, so it must be 0 as well. That is the proof of this theorem. Okay, and then I showed you that example using the absolute value theorem. So there are more than one way to find out the limit of a sequence. Okay, so you can use any one of those method. All right, guys. Thank you. So we will do more examples next.